Hi, I'm Captain Chris Nolan from Sea Semester. I'm a tall ship captain and educator aboard the vessel Robert C. Seamans. Right now I'm ashore, but I'm keeping tabs on the Robert C. Seamans as she makes a journey from Hawaii to Southern California. This is a journey that the USS Iowa used to make quite a bit. And you may have to ask yourself, what's going on between a sailboat and a battleship? How are they similar? Well, it's actually a really interesting question about the paths that these vessels take. The Iowa, for instance, would most likely go directly from Pearl Harbor to Southern California in a straight line. She's a power-driven vessel driven by engines. She's also got an enormous amount of fuel, which is over 2.4 million gallons on board. So she can sail at about 17 knots and get there pretty darn quickly. Contrasting that with a sailing vessel, if you've tracked the journey of the Robert C. Seamans, or if you're ever curious, most sailing vessels, if they're leaving from Hawaii, are going to follow a path like that. And you may ask yourself, why would it do that? Why wouldn't it take the straightest path? Well, the Robert C. Seamans is a lot smaller, it has a lot less fuel, although it does have an engine, and it relies on its sails to get where it's going. So in the Eastern North Pacific Ocean, there's some predominant winds that happen. Where you live in Southern California, you most often see some winds in the summer from the north, right? That means the winds are kind of coming like this, down the coast, maybe bending around Point Conception. Out there in the open ocean, the winds change. If you look at a weather forecast, you're going to see areas of light winds and areas of strong winds. What most often happens out here in the Eastern North Pacific is that there's big, high pressure. That means that air is flowing down from aloft, hitting the surface, and then spreading out. Around a high pressure system, the winds in the northern hemisphere tend to circulate this way. So if you're a sailing vessel, if you take a look at that high pressure system is a big barricade to getting to Southern California. So if you want to take advantage of the winds, it makes the most sense for you to follow this way and then be able to sail as much as possible. How long would it take the Robert C. Seamans to make that journey? Well, she's out there right now on her way to Southern California, and it's going to take about 2 weeks to do that. So you compare that with how quickly the Iowa could make that same transit, and you can see the difference between a sailing vessel and a power vessel. You want to know another really cool thing? Captain Sean Brokaw, who's currently on the Robert C. Seamans making this journey, he's a Navy veteran and actually saw the Iowa when he was in the Navy back in the day. Let's listen to Captain Sean on the satellite telephone.
I believe I saw the Iowa when I was stationed in Diego Garcia. This was back in 1987, a long time ago. But back when the battleships were still in use. But the New Jersey came in one day, and she had to offload some equipment, and then the Iowa came in the next day. It may have been one of the other two, but I'm pretty sure it was the Iowa. Over.
Awesome. And would you estimate that the Iowa makes the journey from Hawaii to Southern California just a little bit faster than you did?
That would be an understatement. Yes. Yeah. We very much took the circuitous route. Being a sailing vessel, we had to go in a big S sort of shape to capture the wind. It worked out well, but it means it's a longer journey than going in a straight line. Over.
Well, I hope that was an interesting discussion about why a sailing vessel and the Iowa might need to take a different route from Hawaii to Southern California.